Hello, everybody. Nice to talk with you. Happy about be doing this presentation today. This is the mission 217. Today is August 25th, 2025. I'm Professor Julio Rezende. I hope you enjoy this presentation about sanitation center on Mars. Okay. These are some topics that will be going deeper in our discussion. Are 20 different topics that we are bringing. The first dimension is related to internal design. Here we can see the location of sanitation center, where is the sanitation center is located, and also other image showing the location of sanitation center. All facilities present a circumference shape with 8 meters of diameter and 3 floors. The facility needs to provide dormitory with beds for astronauts, small kitchen, dining room, toilet, food microproduction with algae and vertical garden, and also the integration of these 3 levels. In this case, we imagine like the level one for water management, also level two wastewater treatment, and level three recycling. A fourth functionality for the sanitation center would be like oxygen production, but this would be other presentation to bring more technical aspects related to uh, air recycling and also the oxygen production. This was like the concept of this specific habitat, the specific uh, site, as like the third level for social and entertainment, sleep and toilet. The second for monitoring and also regenerative systems. And the first for reservoirs, algae cultivation, and laboratory. Yes, and also there is a like the also the ground floor, the first floor, the second floor, also in the ground floor, like a maintenance area, a laboratory, and also algae cultivation, and the first floor, environmental control life support systems operating here, and also like the second floor or also like the third level operating like a small dormitory and kitchen of support of astronauts in like a social area. Yes. uh, Now I'll be talking about applied technologies. We can see some technologies necessary for the operation, like decoupled reservoirs, quality monitoring systems, sewage and wastewater treatment systems, closed loop systems, support technologies like robots or automated systems, bioregenerative life support systems, environmental control life support systems, and also systems of like heating, ventilating, air conditioning, and also related to air filtering and also oxygen production. We can see like a hygiene model to support the station, would be important consider like gray water collection as well as the treatment, also integration of sustainable technologies in building and water management data using IoT. Okay, one moment. Okay. And also closed loop systems integrating bio-waste into bioenergy. These are some technologies to be considered. Necessary approach also for water management technologies, water treatment strategies, and also mixing regeneration with efficient removal of contaminants in human urine. Like also this would be the concept of the oxygen production on Mars, like atmospheric capture of also the happening the water electrolysis and also the oxygen storage and later the oxygen utilization uh, to support the astronauts' lives on Mars. Here you can see like this is very important technology. uh, I believe it was 27 or 2012. This equipment was transported from Earth to International Space Station. Is called the urine processing assembly, and this equipment reduce in terms of 60 or 70% the necessity of water to transport it to International Space Station because this system starts to filter, to treat the urine of astronauts. And this was very important in terms of logistics because reduced the demand of water to transport to International Space Station. And this is a very unique piece of engineering, and we imagine the possibility in the future a system like this also will be operating on Mars. Okay, and this is a representation of space station regenerative environmental control life support systems. How is the flow? It's like a little small, but you can see like how is the process in terms of potable water processing. Okay, also the urine recovery and also the control of temperature, the carbon removal, carbon reduction, and also other processes and how this would be like to be operating as a circular system to support the life of astronauts, International Space Station. But probably for Mars would be we would have something similar to operating on Mars. Also, other technologies, it's very interesting consider the use of algae. The algae would be important to produce the edible biomass, also biofuel, and also conversion of carbon to oxygen. And also the algae would be very important to accelerate the sewage treatment, okay? And also reflecting about some possible resources to generate the seed or transport from Earth. We like these are different concepts. Like for example, how would be how is currently the water recovery and management on International Space Station? Like this diagram explaining this, and also other equipments. For example, bringing how would be the process about bring the solar lightning to accelerate the algae process, like also like a convex mirror to bring the light to inner areas. Yes. Okay, and now I'll be talking about the third dimension of my presentation related to management. And I saw four different positions to operate in these four different astronauts. One responsible for life support systems, engineer or operator, microbiologist, planetary protection officer, and a waste recycling and repurposing specialist, and a sanitation and engineering hygiene technician. For example, the life support system engineer or operator, this would be a technical or mechanical specialist. Some responsibilities are operating, maintaining the complex machinery that recycles the water, and also from urine and humidity. And also, it's very important. Also, a person with skills in terms of troubleshooting. Also, the other specialists related to waste recycling, And these also, we mentioned that a station on Mars would be very fundamental the use of a recycling mindset. For example, these astronauts will be responsible for manage the process of converting trash, such as food packagings, and to be converted to other materials. For example, in our view, we suggest the use of a single plastic. The single plastic would be like grinded and also converted to small particles, and these particles be melted to create filaments. In this case, would be very important the use of a single plastic and also the grinding process to produce the new materials from the single plastic. Third position would be like the microbiologists. These astronauts responsible for biological chemical safety of the sanitation process. He'll be responsible to monitor the microbial environment and also evaluating how would be like also the contaminations between Mars and Earth and Earth and Mars. The fourth position is the sanitation and hygiene technician. Is these astronauts needs to deal to day-to-day operations of the sanitation center, including collection, sorting, initial processing of all waste products. Also will be responsible for maintaining the cleanness and the order of the facility, perform the maintenance inspections. Then we can see like these four astronauts are each one presents a complementary skills, but always being very important for the operation, not only the sanitation center, but but also for the operation of the entire station. We imagine different topics of the for the training of astronauts. For example, one of the topics, like four topics we imagined. Like the first topic would be environmental control life support systems, what they would be training about. They would be training about closed loop systems, water reclamation, and air revitalization. Also, later, can someone watching this presentation can do some stops and to read all the content. Okay. The second topic would be about the training for astronauts to work in this facility would be the waste management, and this would be related to solid waste processing, in situ resources utilization, and also like involving the use of systems to reform plastics into tools or parts for habitats, and also waste to energy conversion. These are also very important and very interesting topic. The third topic of training would be about microbiology and planetary protection. This is related to microbial control, pathogen identification and sterilization, and planetary protection protocols. And the fourth and last topic of our training would be engineering and maintenance connected to systems engineering, repair and fabrication, and robotics and automation too. Related to some videos for astronaut training, we identified like some previous presentations from that happens during our previous missions, and also there is a QR codes that is possible to scan to have more information about. Okay, but were presentations also, some of them done by Savi Souza, a great researcher, like in previous missions of Habitat Marte. Some resources not for 1 week. We measure like also number of members for astronauts. We imagine like the daily consumptions of 2,000 grams per person, and also the week consumption like 14 kilos for each astronaut. Only also knowing that some part of part of this food be consumed. This is just add water to produce the meals, because a lot of this food consumed based in powder. In this case, would be like the food just ready to be consumed. And in this case, would be necessary, like based in our week, in our mission, to multiply for two, because we are this mission is happening during 2 weeks. The water would be like 3 liters for by each participant. Okay. Yes. Okay. Guidelines to be provided to all the facilities. These are would be considered like development of protocols and routines on water management, also research about the use of water, provide clean and potable water, indicators of consumption and control of the water use, safe and recycling practice, and basic guidelines for rendering, preventing, maintenance the water-related systems. Now the fourth dimension of my presentation are the protocols. Yes, some specific protocols for this facility, monitoring routines, conduct tasks on water management, perform preventive maintenance of biological support system, and collect the reports from other stations, other facilities, and compare the data reported by sensors. Protocols of safety, how would be the process of fast isolation, evacuation, hatching order, and keep reliability of the systems. These would be some protocols like of in a situation of emergency operating the sanitation center. In terms of protocol for occupancy and entertainment, we imagine the socialization practice, recreation moments, relaxing areas, and operational activities of the infrastructure involving cultivation of food, interaction with plants. Related to food microproduction, we imagine topics related with food logistics, risk management and avoid losses, monitoring reports, and waste management. Here is the protocols for food microproduction on Habitat Mart that would be also replied in Rio Station on Mars, for example. We present routines of management, maintenance, recycling practice, harvesting and processing. Also, other research activities like the analysis, diagnosis, ensure circularity, orientations, and detection of possible features. Here, the representation about how would be a vertical garden. Related to 3D printing, we imagine would be interesting a special kind of 3D printer to print plastic tubes and sanitation components. Also would be necessary design like in some software, some kinds of tubes that would be necessary to be operating the station. And a lot of these materials would be provided from the plastic. If you are considering the use of single plastic, these plastics would be recycled and melted to be used in extruders to produce this plastic filament, and also to be constructing these tubes. Very important to transport water and also the ventilation in the station. And the last dimension of my presentations is the spin-offs. this photo is not new. Now is Habitat Mart fully renovated, where we can see this water tank. Now is very different, but here some different photos showing the analysis of water and some procedures. And here photo of our sanitation unity. And recently, during July 2025, we installed desalination plant. Here's a photo that was recently installed. And in the future, we'll be putting some boards explaining the operation of the desalination plant. But this was very important because the water consumed in our facilities in Brazil are brought by a water truck. And with this system, if necessary, would be important we produce our own water because we have wells, but the water in the wells are salty, and with the system, will be possible have like a potable water operating this desalination plant. Okay, there's some guidelines to be applied to daily life on Earth. We can see the water's consumption. We can talk about uh, communities on Earth, about the water consumptions, about water saving and economy practice or sustain life, supporting hygiene, investments in research aimed at water reuse systems to be applied in areas with low water availability. And for example, we mentioned about very important technology would be how would be the recycling of gray water. The gray water are waters from the sink and the water sinks and from the bath area from the shower. And this kind of water are contaminated, but would be easier to treat when we are comparing the water with feces and urine. Okay. The impacts of sustainable development goals. We can see like some impacts like water is very important to deal with poverty. Uh, like systems of sanitation is very important to combat poverty and also can promote decent work, and it's very important to sustainable systems when we have the sanitation systems operating. Also deeply connected, the goal six is the deepest connected. Also reduce inequalities, peace and justice. And also the goal 12, the goal 12 is related to also like recycling systems. Yes. Related to research, the topics connected with sanitation center, we can see many topics of different kinds of research. We can, it's a great area of research. For example, we can talk about water recovery and recycling, waste to resource technologies, microbioecology, then closed systems, energy integration, regolith filtration and absorption, human health monitoring via waste analysis, psychological and operational studies, and cross integrations with life support systems. In this case, uh, it's very, very interesting area of research. As I mentioned in one other times that the sanitation center is like the heart of also the lungs and also the intestine of the station, because if something is not working properly would collapse the operation of the station. Okay, and 19th topics is management systems. What kind of resources would be managed by like an application, a computer application? So like a system would control like levels of and the status of water supply and recycling, how is going the flow of the gray water, black water, and also would bring information about waste processing, how many kilos were processed, how many kilos of plastics are being recycled, for example, how many nutrients are being recovered. Because, for example, we can see that a great quantity of salt would be would be recollected from the urine of astronauts, for example, and also other elements like nitrogen, phosphorus, potassium, and yes, and like also the system would bring information about energy usage, like power consumptions of pumps, heaters, UV sterilizers, and also information about air quality, sanitation models, health and safety alerts, and byproduct storage and transfers. And the computer systems would produce it. Also, this image was created by ChatGPT. Would be interesting have like a how would be the levels of water recycling, nutrient recovery, and also the nutrients recovery here, like for example, like the levels, and if is was detected a pathogen, or if it's presented like a system leak, and probably would be like a programmers, computers specialists would be important to help the station to create the systems to control every aspect in the operation of the sanitation center. The last topics is related to quality of life. We can see the importance of space narrative and storytelling design, the astronauts present the mission logs and also take notes about the experience during the life on Mars, on the station, and probably just happening today, many notes from the experience now in the with astronauts in the International Space Station. These notes are transformed in books, and now there is many very good books of astronauts that very interesting stories about the experience of astronauts that emerged from these notes that were collected during the time in the International Space Station. Yes. Okay, these are some references interesting to be considered. Yes, this is my presentation. I hope that you like it, and also see other presentations in our YouTube channel. Okay, thanks so much.